Let's do a quick refresher on the long division of for polynomials. And this is more of a continuation video while we are solving type 4 partial fractions, and specifically we're talking about improper fractions as one of the types. And if you see in the last episode, if you're not seen, please check out the last episode where we were, I think I was giving the intro. This will be the episode name, partial fractions type 4 improper fractions, some intro and some background. In that episode, if you see, where we concluded is we understood how do we do this long division in the context of improper fractions, and we also understood what is a mixed fraction, and we were trying to apply the same concepts to the polynomial world. And where we stopped was improper fractions in polynomials. First we will express them whenever we have a type 4 improper fractions in polynomials. We'll first express them in a mixed format, which means that we'll have a whole polynomial and then we'll have another part added to that, which will be in a proper partial fraction format, and then we can solve this separately. That's what we understood. In today's episode, what we'll do is we'll just apply those learnings. If you remember, this is what I'm talking about. How do we do the division, and then how do we get to this particular formula? We'll exactly use these both concepts in the context of polynomials and rational expression, and then try to solve an actual problem. Okay, so the actual problem that I'm going to solve is in the next episode, which is more of an exam problem. I've taken it here, where you see the degree of the numerator is greater than denominator. But for the sake of example, this episode is all about how to do the long division for polynomials. A quick refresher, we must have learned this in the elementary maths, but let's understand. Okay, and for the sake of simplicity, don't worry, I'm going to take this example, but this is technically not not an improper fraction. It is an improper fraction in the context that the numerator is greater than the denominator, but this also we can factorize this in x minus 2 the whole square, but doesn't matter because the numerator is still bigger. So we'll have to use only division to solve this problem. Okay, so let's focus on the division problem, how to do the division. So let's say if this was your given problem, in which case we have a dividend and in the bottom we have a divisor. Okay, these are the terms that you need to remember. So if I do this division over here, what does this division actually mean? So you have a divisor here, whatever is in the denominator, and then we have something inside the division world where we are going to use the dividend. So all we need to do is, we have a x square and we have x cube. So all we need to do is somehow we need to get a factor, this line item where something is in x cube, so that the x cube gets cancelled when I subtract these two line items. So we have a x square and I need an x cube over here. So what do? I just multiply it by x. So let's say you take the first term in the quotient as x, and if you multiply this whole puppy here with x, what do we get? We get this line item. X to the power 2 into x is x cube minus 4x square plus 4x. And then what we do is we kind of divide those two line items, just like any other division that we do in any context of the numbers also, right? So what we do is we just divide this. So this will have all negative signs, not divide this. We are going to subtract these two line items. We are going to subtract this one from this one. When I do that, this x cube minus x cube gets cancelled. I get 0. So plus 4x minus of minus will become plus, then we get 8x square, and then again we get minus 6x, and then we take the last constant term and we put it here. So that way what we have got is we have got a new term. We have done the first step, and now we are going to, this is your new remainder, and now we are going to see if we can continue the division. Okay, as long as the power of this and the power of this, for example the power of the divisor, as long as it's greater than or equal to this, we can keep dividing. In this case it's equal, right? Both are 2, so we can still go on with the division because there is some number which we can multiply and we can still get 8x square. And what is that? Plus 8. If you just do a plus 8 here and just multiply this by 8, what do we get is this line item, 8x square minus 32x plus 32. Okay, this is what we get. And again when you kind of divide, when you kind of subtract, you subtract this piece from this piece, the 8x square gets cancelled, and then you get 26x minus 37. Okay, that's what you get. So that way you divide the polynomials. And when do you stop? Here we are stopping it. Why are we stopping? Because the degree of the x over here is 1, which is less than the degree over here is 2. So we cannot divide it. There is no number that we can multiply so that we can get a x1 here. So whenever the degree of the remainder becomes less in terms of the polynomial power than the divisor, okay, then you stop. This is exactly what we did in the number system. Whenever your remainder was less as a number than the divisor, we stopped it. So the same concept, instead of the whole number, we're talking about the degree of x, and then we stop it. That means we cannot divide this anymore, we stop it. And as soon as you stop it, you'll realize that you have a quotient, and then you have a divisor, and you have a remainder. And the remainder, since the degree has become less, in a way you're getting a partial fraction, because once you put in the next step, you'll see that you're getting a partial fraction. So that's your clue, that once your objective was to get a partial fraction as one of the components when you solve this, and you're getting it now. And then the last step, what do you do that? You express them in the format just exactly how we use this formula over here. If you remember this one, how we used for the numbers, we're going to use the same construct to express the polynomials, okay? And that I've copied it here for simplicity. If you see at the bottom, this is what we have got, and I've copied the exact same thing over here, okay? And I applied this formula. So dividend over divisor is equal to quotient plus remainder over divisor. And if you see, this is what it is. So I have the given problem. So let's say this was your given problem of an improper fraction, and this is what we wanted to decompose into a partial fraction. And what I've done is I've converted this into a mixed format, where I have got some linear factors or some whole factors, plus I have a partial fraction, but this partial fraction is a proper fraction since the degree of the numerator is less than the denominator. Degree of the numerator is less than the denominator. And once I get that, I can just take this and apply either type 1 or type 2 on type 3 based on what it is, and then solve it all by itself, and then do the factorization and stuff like that. In this case, if you see here, if I were to solve, I know the denominator can be factorized as x minus 2 the whole square. Okay, that means this is going to be a type 2, because I'm going to get a repeating linear factor. X minus 2 the whole square can be expressed as x minus 2 into x minus 2. So I'm going to get linear factors, but they are repeating in nature. So I'm going to apply type 2. And that's how I'll solve this problem. And then this x plus 8, you should not forget, but you don't have to do anything about that. So that's how you solve. So the trick is, what is the trick? Whenever you get improper fraction in the context of polynomials, use the long division to express the improper fraction as a mixed fraction polynomial. And what does it mean? A polynomial where you have got two parts. One is a whole polynomial, or something that you don't have to worry about because it's already in a linear format, and plus you have another component which is a proper partial fraction in terms of polynomials, because you still have polynomials in the numerator and denominator here, but the whole construct is proper because the degree of the numerator is less than the denominator. And then you apply any of the three types that you know to solve this problem. That's how you kind of do solve a type 4 improper fraction. The first step is to bring it to a point where there is some proper fraction in that, and then apply the first three types or one of the types to solve the problem. That's how we solve this problem, and that's how we do the long division. And this was a quick refresh on the long division. If you already know how to do the long division, you can skip this episode and go to the next one. In the next episode, we are going to solve this problem in detail from top to bottom, applying the concepts that we have learned in this episode and in the previous episode.